Today we will see what is the need of analog to digital conversion. Why we need to convert the data from analog signal into the digital signals, that we will see today. Every sensor will going to generate the data in analog format, and microcontroller understands only digital data, which will be in the form of zeros and ones. So remember two things: all the sensors will going to generate the data which will be in your analog format, but microcontroller will not going to understand that particular data. What microcontroller will understand? It will understand only the data which will be in your zeros and one, that is in your digital format. So an intermediate device is needed that will convert sensors analog data into microcontrollers digital data. So we will be requiring one intermediate data that will going to convert sensors analog data into microcontrollers digital data. That intermediate device is nothing but your analog digital converter or ADC. So this particular converter will going to convert analog data of your sensor into the digital data of your microcontroller. It is an electronic integrated circuit which will convert analog signal into digital signal. So whenever any sensor will going to generate any data, that data will be in the form of your analog data, but microcontroller, or let's say our system, will not going to understand this particular analog data. What system will understand? System will usually understand the data which will be in digital format, that will be in your either zeros or one. Strictly digital data will be understand by your microcontroller or microprocessor or any of the system. So in that case we will be requiring one converter. That converter will going to convert your sensor data into your microcontroller or system understandable format. That is why we are going to use analog to digital conversion or analog to digital converter, which will going to convert analog to digital data, which will be understanding by the system or any microcontroller or microprocessors. There are different analog digital converters such as 12-bit, 14-bit, 16-bit, 24-bit, etc. So these are some ADCs available depending on the size of their bus. You all are aware about that. This is your analog signal. Analog signal will be like this only. So this analog signal which is generated by your sensor, or whatever data will be generated by the sensor, will be in this format. It will be in this analog format. We will be using one A to D converter. That A to D converter will going to convert analog signal into digital signal, which will be in your zeros and one format always. So you can see this will be your 0, this will be 1. So this waveform will be your 0 and 1, that is your digital with respect to your time, and this will be your analog. So there is one converter which will going to convert your analog signal into digital signal, which is understandable by the microcontrollers. Now we will see the logical design of IoT functional blocks, which are various IoT functional blocks that we will see here. It is an abstract representation of the entities and processes without going into the low level specifications of the implementation. So the name itself suggests that we are going to see the logical design of IoT. We are not going to see in detail design of IoT. What we are going to see is we are going to see only the logical design, that is your IoT functional block. And what exactly that particular logical design of IoT is? It is abstract representation of various entities and different processes that we are going to use to develop any IoT application, but we are not going to go in detail about that particular entities and processes, how those processes has written, how those entities have been implemented. That we are not going to see in detail. We are just going to see the abstract representation of IoT. That is nothing but your what? Logical design. An IoT system comprises of number of functional blocks that provide the system the capability for number one, identification, sensing, actuation, communication, and management. So we are going to design such IoT system that will be comprises of n number of functional block diagrams or functional blocks that provide the system capabilities for what exactly that IoT system will going to do, what are the capabilities of any of the IoT system. So the capabilities can be, it can identify the objects, it can sense the object, it can perform the actuations, it can do the communication. Communication means what? The data will be generated by one sensor and it will be transferred to the another system, it will be transferred to the server, or it will be transferred to the cloud. That is, the communication will take place between various IoT devices in your single IoT application. So the communication can also be takes place by your IoT system. And the last point will be the management. The application should be managed to perform various tasks, various functions, or various operations in your IoT application. That is nothing but these are some capabilities that an IoT system can perform: identification, sensing, actuation, communication, and management. Here, communication can be treated as the data exchange between various nodes or the data exchange between various IoT devices. Either data can be sent or data can be received, or data can be sent and received. Can be treated as your what? Communication between various IoT devices in your IoT application or IoT system. So at the basic level of your IoT functional block, or at the basic level of your logical design of IoT, we will be having various IoT devices. Then all those IoT devices can have the functionality of management. They are going to manage various tasks or various functions. Then all those things will have proper security. Security will be the most important thing in case of any of the IoT application, because whatever data is going to generate by the IoT system, that data needs to be protected from third party hackers. If that particular data is going to be hacked by any of the third party person, that person may change your data and it may lead to your what? Misleading activities. So the security will be very important in case of your what? IoT application, because everything will be online, everything will be through your either wired network or it will be your wireless network. So data security, network security, infrastructure security, all the types of security is very much important in case of your IoT application. Then there will be the communication between various devices. Those communication, as I already told you, the communication can be either data sending, data receiving, or data sending as well as receiving will be the type of your what? Communication that can be takes place in case of your IoT application. Then there will be various services that can be used by the IoT application, and those services can be used by IoT application to complete some functionality or to complete some task for which that particular IoT system has been designed. So some services are built-in services, whereas some services are third-party services, but all those services are very much important in case of IoT application, because these services will be given to your what? Communication purpose through your various IoT devices. Security can be given by using some third party services. That's why the services are very important. And at the top of this particular IoT functional blocks, there will be one more layer, that is nothing but your application layer. And all the IoT application will going to use your management, services, communication, and security of your IoT devices for that particular IoT application. So these are two parallel layers of your application and devices which will going to use all those intermediate levels of your IoT application. That means your management, services, communication, and security. Security is very important from application point of view. Security is very important from device point of view. Security is again very important from communication, that means from data point of view, and security again is very important from various services point of view. So that's why it is shown as vertical for your what, this IoT block diagram. So this is what your logical design of IoT, that is your IoT functional blocks. Now we will see various IoT enabling technologies. So the first one is your wireless sensor network. Second one is your cloud computing. Third one is big data analytics. Then next one is your communication protocol. And last one is your embedded system. Now we will see all those IoT enabling technologies in detail. So the very first one is your wireless sensor network. The name itself suggests that it is a group of sensors connected in wireless network, right? It is one type of network having nature wireless, and what it will going to have, it will going to have various sensors embedded in that particular network. So wireless sensor network, it is a group of sensors connected in wireless network. This WSN will going to monitor and record physical conditions of environment and store collected data at central location. Whatever will be the physical conditions of environment, all those physical conditions will be recorded, all those conditions will be monitored, and that particular data is stored at central location with the help of your what, this wireless network. For example, it will going to record room temperature, sound, pollution, humidity, etc. So wireless sensor, the particular sensor what we are going to use is, it will going to record various physical conditions. So if we consider, let's say, what we can see here, these balls are nothing but your what, various sensor node. The data will going to generate by these various sensors. All those data will going to transmit to your what, server via one particular network. That network will be your wireless in nature. So this particular diagram will going to tell you that this is your network which will have various sensors, and that network is wireless in nature up till this gateway sensor node. And from this particular sensor node, it will be your what, data will be transmit to your either server or it will be transmit to your cloud. That is nothing but your wireless sensor network. Then next is cloud computing. Cloud computing is the shared pools of configurable computer system resources and higher level services. It is one kind of your pool where so many things are available. Those so many things are nothing but your computer system resources and higher level services. So in case of your cloud computing, there is one huge cloud, and that particular cloud will going to have various resources and some services that can be used by the user as a part of your cloud computing service. It can be rapidly provisioned with minimal management effort, often over the internet. Usually the cloud computing services can be used over the internet. Internet is must. If you are going to use your cloud computing services, you must be required what, internet services. It relies on sharing of resources to achieve consistency and economies of scale similar to your public utility. So it is what, huge in nature, its scale is very big, and it is consistently used. It will going to have some sharing resources, and one resource can be shared with among various users. So this is what we can say the block diagram for your cloud computing. What you can see, this is your cloud. Whatever you can see, the border is nothing but your cloud, and all the things in between your that particular cloud is nothing but various, let's say, application or platform or infrastructure. So all these things are placed at one location, at one cloud, and you can use those particular services or application or platform using your server desktop, tablet, phones or laptop, but strictly through internet. Then it will be treated as your what? Cloud computing. The best example of your cloud computing services or computer system resources is nothing but your Google Cloud. When you are using your Google Drive, that particular Google Drive is nothing but your what? One cloud. There you can create your spreadsheet. That spreadsheet can be shared with multiple users. Multiple user can going to update that particular spreadsheet at one time. All users can update the spreadsheet at one time. Remember this, if you remember the example of spreadsheet. So this is the best example of your what? Any of the cloud. Or another example of your cloud is nothing but your Amazon cloud. There are n number of things, big cloud, n number of clouds are there. All those clouds will have some predefined applications, pre-install application are there. They will have some platforms over there like database or identity management, storage management, like this. Or it will have some kind of your pre-defined or pre-used infrastructure like your computing system, storage system, and you will have some network. And what will be the task of user? User will going to access these particular things through their particular device using internet. That is nothing but your cloud computing. Third one is your big data analytics. The complex process of examining large and varied data sets to find information like hidden pattern, unknown correlation, market trends, customer preferences, etc. The name itself suggests that big data is nothing but the huge amount of data generated with the help of your internet. And whatever processing you are going to do on that particular big data is nothing but your big data analysis. So it is one type of your complex process which is usually done on various set of data, set of customers. That customer will going to provide some feedback, and on the basis of some feedback we will come to know the customer preferences or customer choice. We are going to identify the market trend, where exactly the market is going on. We are trying to find out some hidden pattern from the data analysis or big data analysis. So it is one type of your what? Complex process for examining large and varied data set. So it will have huge number of data, and that particular huge number of data will going to generate some analysis part. Let's say the example of big data analysis or big data is nothing but today all over world is going to use WhatsApp or Facebook. The message or audio video files that is sent over the internet through your WhatsApp will be huge amount of data is going to send daily from WhatsApp to WhatsApp. So just imagine how many users are there. If one user is going to generate that much of data, multiply by n number of users, you will try to get the volume of data generated daily through only single WhatsApp. Now we have Facebook also, we have Instagram also, we have so many social media sites, and you can imagine how many data can be generated using all those social media sites. And whatever analysis will be done on those particular data, that will be treated as your what? Big data analytics. It can help organizations make informed business decision. It will help forward taking some decisions related with your businesses. So you can see in this diagram here, all these things, all those symbols are your what? Social media symbol. If you can see here, Facebook, Twitter, Instagram, Pinterest, and so on. All those particular social media are going to generate some amount of data. That data is going to be processed. That processing is nothing but your big data analytics. And after this particular thing, what will happen? There will be some analysis, there will be some output, and that particular output will help for taking some business decisions. So that is what your big data analytics or big data analysis is. Then next is your embedded system that we are already looking for. It is the combination of your computer hardware and software. Point number one. Embedded systems are either fixed in capability or programmable, designed for specific function or various functions. As you all are aware about that, they are specifically designed for performing some specific task or specific function. Embedded systems, these are some computing systems but can range from having no user interface to complex graphical user interface. In case of your embedded system, they either have no user interface to some complex graphical user interface, and it is one type of your what computing system. User interfaces can be either your buttons, LEDs, touch screen, that can be either your sensing, touching, and all those things can be treated as your what various user interfaces. So whatever we are going to use as a touch screen, that is a combination of your hardware and software, which is an example of your embedded system.